Probably distribution for deck cards. I know in your notes these are in a different order, so keep that in mind as we're going through this table. I think is the middle table, isn't it?
Yes.
Okay. So let's start with the suits thing. That's on the left for you guys. So how many clubs are there in a deck of cards? 13 out of 52. Which reduces to 1/4. How many diamonds are there? 13 out of 52, right? So that's also 1/4. How many spades are there? 13, which reduces to 1/4. 13 out of 52. Hearts. 13 out of 52, which reduces to 1/4. Any questions? Any questions? Does that make sense?
Yep.
So if I take a deck of cards and draw a card at random, all 4 suits are equally as probable because they all have the same probability. Does that make sense, guys? Okay. What about drawing a 2? How many 2s are there? 4 out of 52. What does that reduce to? 1/13. Okay. How many 3s are there? 4 out of 52, right? Every one of these cards, there's 4 of each in a deck of cards, right? So every one of these is equally as probable with 1 out of 13. Now you're probably saying, well, Mr. Branch, when I'm playing Go Fish, how come I can never get the card I need? Anybody thinking that?
Yeah, but
Or any other card game besides Go Fish? Okay. The reason why you play when you play Go Fish or War, whatever it is, why you can't get the card you need, or why it seems like you can't get the card you need, is because there's only 1 out of 13 chance to get the card you need, right? What's the probability you don't get the card you need? 12 out of 13, right? 1 out of 13 for the card you need, 12 out of 13 for the card you don't need. Okay, does that make sense? That's why it always feels like you can't get the card you need. Every card is equally as probable, but when you think about the one specific that you need compared to the rest, probably 1 out of 13 for the one you need, and 12 out of 13 for the one you don't. Okay? It's a not statement, right? 1 minus 1 out of 13 is 12 out of 13. Does that make sense? Any questions? All right, let's try these ones. What's the probability of getting a club? 13 out of 52 or? 1/4. That's what a probability distribution tells us. It tells us the probability of getting that outcome, right? So the probability of drawing a club at random is 1/4. Right? First on the table. Probability of getting a king. 1/13, right? Thank you, Whitney. What? Because 4 out of 52 reduces to 1/13. Right? Okay. What's the probability of 3 and clubs?
1.
Okay. Well, if 3 is 1/13, a club is 1/4, so 1/13 times 1/4 is 1 out of 52. Okay. 1 out of 52. Right. Or you can think of it this way: how many 3 of clubs are there in a deck of cards? 1 out of 52, right? So either you can do the multiplication, or you can say, well, there's only 1 3 of clubs and there's 52 cards, so the chance of drawing a 3 of clubs is 1 out of 52. All right, red is for the spinner, so we'll come back to that. Probability of an ace or a heart. How many aces are there?
4.
Out of, okay, plus,
4.
how many hearts are there?
13.
13 out of 52, right?
Yeah.
How many aces of hearts are there?
1.
1. We've counted in both of these, haven't we? So I need to subtract 1 out of 52. Okay? So 4 plus 13 makes 17. 17 minus 1 makes 16 out of 52. That's the probability of drawing an ace or a heart. Yep, reduce if we can. So I can take a 4 on the top, I can take a 4 on the bottom, and I get 4/13. Does that make sense, guys? Okay, does that make sense? Okay. So right now, is this new stuff so far?
Yeah.
No, this is just review. Okay? Probability of not a jack. How many jacks are there? 4 out of 52. So not a jack means 1 minus 4 out of 52. So what does that leave me with? 48 out of 52. Good. What does 48 out of 52 reduce to? 12 13. Of the answer keys? Yes, fine. There's some right there too. You can just take them all down if you want to and put them on the table, or you can just take them right there. All right. Any questions? Any questions? All right. Let's go to the 8-section spinner. How many total outcomes are there? 8. How many of those outcomes are black? 1. So what's the probability of spinning black? 1 out of 8. Make sense? Yeah. Blue. How many blues are there? 1. So what's the probability? Good. What about green? 2 out of 8, which reduces to 1/4. Red. 4 out of 8, which reduces to 1/2, right? So what's the most probable outcome? See, Kim? Red. What's the least probable outcome? Black and blue, right? Getting a black on a spin or getting a blue on a spin. Those are the least probable. All right. Does this make sense? Yeah. So you guys have just made a probability distribution. So what's the probability I spin red? 1/2. Half my spin should be red. What's the probability I should spin blue or green? Or means add. So we add blue and green. Okay. 1/8 plus 1/4. And then we got to subtract the overlap, right? Is it possible to have blue and green on one spin? No. Yep, so it's 1/8 plus 1/4 because blue is 1/8, green is 1/4.
Oh, that makes it blue.
Okay. Or I could write, instead of 1/4, I could write 2/8, which will make it easier to add. Right? And it's impossible to get blue and green on the same spin, right? So what do we subtract from this? 0, right? So then you get 3/8. What's the probability of not black? 1 minus 1/8, right? Right, what does that equal? 7/8. Take them off my screen. Okay. Does that make sense? Are there any questions? Okay. Now, you guys need these probability tables filled in. That's why I had to do it. So, have those probability tables accessible because we're going to need them here in a second. All right, any questions before we move on? 7/8, because 1 is 8/8, right? So 8/8 minus 1/8. You subtract the numbers on top and leave the numbers on bottom the same. All right. Anyone else? No? No further questions? All right. Consecutive probability. All right. So on your notes, what's in orange you already have written on your notes. You don't need to write that down. But there are 2 spots that have asterisks. The 2 asterisks go with the blue one and the one just below the blue one. Okay? So, the word consecutive. Who knows what consecutive means? Consistent. So, if I'm playing baseball and I get consecutive hits, that means on my first at bat I got a hit, and then my next time up I got a hit, right? If I get consecutive text messages from the same person, right? That means I get a text message from that person and then again, right? If I'm a Detroit Piston and I miss consecutive shots, right? That means that I didn't make my basket twice in a row. Does that make sense? Right? If you win consecutive games of whatever, that means you win them in a row, right? 2 consecutive means you win 2 in a row. 3 consecutive, 3 in a row. 4 consecutive, 4 in a row. All right? We get the idea of consecutive. All right. So when we're talking about consecutive probability, we're finding the probability of events happening one after another. All right? A and B are consecutive events if A and B happen one after another. Does anybody notice a difference in text color? There is. Why would I make that text color different? Not because I'm creative. Because I'm giving you a hint. A and B. In probability, what does and mean? What does it mean? Times. And means to multiply probabilities, right?
Yes.
So what this is saying is if I'm doing consecutive probability, the probability of event A and event B occurring consecutively is probability of A times probability of B. Okay? Because we're assuming these events are independent. Right? So consecutive probability, guys, is not anything new. All it is multiplication. Just multiplication. So then some of you are probably saying, why are you still teaching me today if there's nothing new? Right? Because there's a couple of nuances we need to talk about. Right?
But you said it's not new.
Well, the multiplication part's not new. You can multiply fractions. I hope so. Alright, we good? Got both stars written down? Jamara, got both those star statements written down? Okay, Jenna? Well, I have the statement in blue that has a star, and the statement just below the one in blue that has a star. Okay? And the statement that's just below the one in blue that ends the probability of event A and event B occurring consecutively is A times B. So this is the end of that statement.
I just put A times B.
Make sure you put a P in front of it. Probability of A times probability of B. I don't know. Alright. What is the probability of spinning consecutive green sectors? Is who? Christine? No. Sorry. What is the probability of spinning consecutive green sectors? Well, how many green sectors do we have? 2 out of 8, right? So what's the probability of spinning green? 2 out of 8, right? So the probability of green is 2 out of 8. So then spinning consecutive green sectors means we do 2 out of 8 times 2 out of 8. 2 times 2 is 4. 8 times 8 is 64. So that reduces to 1/16. Yeah. Does that make sense? Does that make sense? Yeah? Okay. Jessica, Jamara, make sense?
Yeah.
Yeah? You good? Okay. What is the probability it takes 4 spins to spin a black sector? Alright? So, if it takes 4 spins to spin a black sector, that means I'm spinning 4 times, right? Right? I'm spinning 4 times. On the first spin, what did I get? Did I get a black sector? No. We got not black, right? On the second spin, what did we get? Not black, right? On the third spin, what did we get? Not black. On the fourth spin, what did we get? Black. Right? So this is like a big, long and statement. It says, I spin once, I get not black. And I spin second, I get not black. And third, I get not black. And fourth, I get black. It's 4 terms in a big and statement. This, and this, and this, and this. Okay? That and means to do what? Multiply. So that means I need to take these probabilities and multiply. So what's the probability of not black? How many sectors are not black? 7 out of 8. Right? What's the probability of not black? 7 out of 8. 7 out of 8, right? Probability of black. 1 out of 8. So in order to figure this out, we need to multiply all those probabilities together. 7 out of 8 times 7 out of 8 times 7 out of 8 times 1 out of 8. Because the last time we get black. So this one will be 7 out of 8 times 7 out of 8 times 7 out of 8 times what long? 1 out of 8. Good. So the first three are not spinning black, and the last one is spinning black. You see how A and B are different from each other? You guys see how A and B are different from each other? Okay. So what does this equal? 7 times 7 times 7 times 1 times 8 times 8, or divide by 8 times 8 times 8 times 8. So 7 divide 8. What do we get? 343 out of 4,096. So that means if I spun the wheel 4 times consecutively, 343 times. If I spin the wheel 4 times consecutively for 4,096 times, only 343 times it takes me three turns to spin on the black side. Okay, kind of a lot there. All right. Or you can think about it this way. If I leave it as a division problem, 343 divided by 496, it's 0.084. Right? 0.084. That means it has an 8.4% chance of this happening. It means there's an 8.4% chance of it taking three spins to get a black, or 4 spins to get a black. Okay? Does that make sense? Any questions? No? Okay, deck of cards. How many options are there in a deck of cards? 52, right? That's 52 total cards. So, if I'm going to do example C, where it says, what is the probability of drawing consecutive 2s if you return the card to the deck? So what that means is I'm going to take a deck of cards, and I'm going to draw a 2 on back-to-back draws. So let me cheat a little bit here. Okay? So here I have a 2, right? So what they're saying is I'm going to take the deck, I'm going to fan it out, I'm going to draw 2. Okay? Then I'm going to put the card back in. Why is it important that I put the card back in?
So it's still 1 out of 52.
Good. So 52, good. So if I have this card out, I only have 51 cards in my hand, right? So if I draw it and throw it away, I've changed my probability. First off, there's only 3 2s left, right? And there's only 51 cards in my hand. So I've changed the probability. So by putting it back in, I'm keeping the probability the same each time. Right? We'll come back and see what happens if we take it out in a second. All right? So take a 2 out, first draw, put it back, take a 2 out, second draw. That's what they're saying we're doing. All right? So what's the probability to take a 2 on the first draw? 1 out of 52. That's our first draw, right? What's the probability to take a 2 on the... Oh, is it 1 out of 52? How many 2s are there? 4 out of 52, right? Okay. What's the probability to take a 2 on the second draw? 4 out of 52, which then equals 16 out of something. 2 times 52. Okay. Thank you, Bruno. 2704. That's a lot. That's a big probability. It's a big bottom, right? So 16 divided by 2704 is 0.00592. Right? So that means I have basically a 0.5% chance of drawing a 2 twice in a row. Unless you stack the deck like I just did. Does that make sense? Guys, does that make sense? Okay. I can reduce this, which some of you probably did, and you get 1 out of 169. Any questions about example C?
No.
Let's try example D then. Jonah, pick your head up. What is the probability it takes 5 draws to draw a black jack? Well, how many black jacks are there?
One.
Oh, there's more than one.
2.
2. Right? There are 2 black jacks, so it's 2 out of 52. Right?
Or 1 out of 26.
Or 1 out of 26. Right? So I have 2 out of 52 cards that I'm looking for. It takes me 5 draws. So that means how many times do I not get a black jack?
3.
What do you mean?
4 times. On my 5th draw. Okay? So it's like doing this. Right? So on my deck cards, it's like saying, nope. 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 That's 3. Nope. That's 4. Yep. Nah. Someone messed with my deck. Yep. On the 5th draw. Okay? So having 4 draws without a blackjack, and then having 1 with 1. Okay? Does that make sense? So first draw, and it's not off the top. It'd be like if I fan the card out.
You said there's 2 out of 52,
Right, there's 2 blackjacks out of 52.
right?
Either the jack of spades or the jack of clubs.
Right, so then why would it take 5 tries?
It's saying what if it did? What's the probability of it taking 5 tries? Okay. I'm not saying it's going to take 5 tries every time. It could take you more than 5. It could take you 50 tries. Right? It could take you more than 50 to keep putting the cards back in. Right? It's just saying what is the probability it did take 50. It did take 5 tries. Alright, does that make sense, Shemaya? Does that make sense? Yeah? Okay. So 5 tries means the first 4 were unsuccessful and the 5th one was successful, right? So if this is the probability of a blackjack, what's the probability of not a blackjack? Good. 50 out of 52. So if I want to find the probability it takes 5 draws to draw a blackjack, then you need to do 50 out of 52 times 50 out of 52. Remember, putting the cards back. Times 50 out of 52 times 50 out of 52 times 2 out of 52. So these are, we didn't get it, right? Then we got it. Okay? Didn't draw, didn't draw, didn't draw, didn't draw, got it. Okay? Let's figure it out. So what do we get? $1,250,000. Yeah. So, are you guys at the tops and the bottoms? So you get this. 12,500,000 over 38020432, right? Or you can just plug it in your calculator, the way it's shown on the board. 50 over 52 times 50 over 52 times 50 over 52 times 50 over 52 times 2 over 52. Okay. Plug it all in like that. And then you'll get one thing, I gotta catch back up. Then you'll get 0.0329. And it will not math frac that for you. So I'm okay with you giving me this answer, that's fine. Okay?
Why wouldn't it?
Because the numbers are too big. Your calculator will not give you this as a fraction. The numbers are too big. Okay. So what this means is that you have a 3% chance of it taking 5 tries to get a blackjack. Okay? Jamar, does that make better sense now? Of all the tries it could take you to get a blackjack, you have a 3% chance of it taking 5 tries. Okay? Any questions? Any questions? No? Okay. So, in the green box it says, how would it change if we did not put the cards back? So what that means is I'm going to do part C, I'm looking for 2s, right? Probably drawing consecutive 2s, and I'm not going to put the cards back. So I'm going to draw my first two. I have my first two, and then what am I going to do with it? Set it down. So how many do I have now in my hand? I have 51. How many of them are 2s? 3. Does that change our probability? Yeah. Okay. So instead of our first one would be the same, 4 out of 52. But then our second one would be 3 out of 51. Because I got a 2, and I kept it out. So what does that do? 4 out of 52 times 3 divided 51. We get 0.0, 102. 2 zeros. 4, 5, 2. So what happened to our probability? Did it go up or down?
No.
It went down. We have more probability if I put the card back and drawing consecutive 2s. Your calculator, we'll write this one as a fraction. It's 1 out of 221. Does that make sense? Yeah. How does this one change? Does the first one change? No. We start with 50 possible not blackjacks out of 52, right? Now if I draw a card and it's not a blackjack and I keep it out, what happens to the top number? Goes down by how much? 1. What happens to the bottom number? Goes down, right? So 49 out of 51. I draw again, it's not a blackjack, so I keep it out. So I get 48 out of 50, right? So on my third draw, at 40 out of 50, I draw one, it's not a blackjack, I keep it out, right? So now I have, how many are left? 47 out of 49. Okay. So those are my 4 not blackjacks, right? Right? So I'm going to keep this one out. So how many are left? 48, right? I'm going to keep this 47 and 49. I'm going to keep that card out. That's 0.0352. I'm going to keep that card out so we still have 48s. But have I taken any blackjacks yet? No. So we have 2 blackjacks still. Okay. So then we can multiply through and figure this out. Seriously, just type it in the way it is. 50 divided by 52 times 49 divided by 51 times 48 divided 50 times 47 divided 49 times 2 divided 48. Hit enter. Now, how do these probabilities compare? It went up a little bit, right? So if you're trying to get consecutive cards, leaving a card out decreases your probability. If you're trying to find a card, keeping the ones out that aren't that card increases your probability. All right, are there any questions? No questions? No questions?